Hi guys, you're welcome to my channel. So today we are going to be looking at Physics WAEC 2023 practical. I must appreciate every one of you for subscribing to this channel. If you are new to this channel, don't forget to subscribe, like this video and share. Please comment what you learn in this video. Comment it in the comment section, or your suggestion or question. I'll definitely respond. If you like this video and comment on it, it's going to help YouTube algorithm to suggest this to others who also need this kind of content. Remember, it is WAEC. Nobody is taking first position. If you take first position, it doesn't affect anybody. So let us all pass. But before I go on with what I want to be doing today, I want you guys to understand the importance of it. The importance of what I want to do now, unlike before that we just go straight forward to carrying out the practical and the likes. No, I want you guys to depend on yourself. I want you to build your ability to put solution to any physics problem, both practical and theory. I don't want a situation whereby you just depend on this channel only, either as a teacher or as a student. And that's why I want to quickly do this kind of a video to enlighten you before the main question for this particular practical. So I'm starting with question number 3, which is electricity. This aspect of physics is something that is inevitable on every exam, either IGCSE, GCE, NECO, or WAEC, whatever the exam might be. Electricity will always be tested. And it is question number 3. You and I know that. So if we know that, why is it still difficult for us to handle? I was able to answer that question, and that's the reason why I quickly want to point out things that make it difficult for you to carry out experiments on electricity successfully. Either the setup is not working, or the setup is working, you are not getting the actual results, or you get the actual results but you are doubting. Please pay maximum attention. So let's get started. This year, WAEC provide us with the following. We are asked to provide one ohm standard resistor, 1 ohms standard resistor, rheostat, voltmeter, key, or you call it switched, source of EMF, that is battery. Then you have 10 connecting wires. 10 connecting wires. Then we have resistance box. Okay, so meter bridge and jockey. Okay, so when you look at this now, these are the things that WAEC expects every school to provide. And giving you this is to guide you on what the experiment is going to be. Why I'm taking it from the very grassroots like this is because of the teachers. Are you getting it now? But it's also useful for you as a student, because some of your teachers might not bother to look for information about this, and they might present you with the wrong thing. In order to help your fellow students, you can put them through by what you want to learn. Now, these are the things expected of every school. That is, to carry out this experiment number 3, we need all of the following. Now, what's the function of all this? Now, the first thing you want to know is that having resistance, rheostat, voltmeter, key, source of EMF, that is battery, connecting wires, resistance box, forget about these two first. Are you getting it now? Forget about meter bridge and jockey. If I have this following, that is 1, 2, 3, 4, 5, 6, 7. If I have these 7 items, no doubts, the experiment they want to verify is Ohm's law. Am I making sense now? Is what? Ohm's law. Now, what will I now do? The first thing I want to do is to be able to come up with a circuit diagram to represent what? A good connection of all of this in order to verify Ohm's law. Now, let me use this to give you a few brief or look on how your circuit diagram is going to look like. Remember, whenever you have ammeter in a circuit, it should be in what? Series. And whenever you have what? Voltmeter in a circuit, it should be in what? Parallel. If you understand this, then you can come up with a circuit diagram for virtually any experiment. So let's quickly have a circuit diagram, because one of the things that you need to always look out for in experiments that has to do with electricity is to see the what? Circuit diagram. If you're able to see the circuit diagram, the connection becomes easy. So I'm going to explain how to interpret the circuit diagram so that you understand that better, because if you don't understand that, then there's no way you can have a successful connection. Not having a successful connection will prompt you to have a wrong reading or not being able to pick reading at all. So now let's see this diagram here. If I have a cell and I connect this cell to a key, and this key is connected to a rheostat, and the rheostat is then connected to another resistance. Let's say this is resistance box, and then here I have what? An ammeter that is connected in series. Okay, so if this is what I have, I need to take this diagram down a bit. So take this down a bit. Okay, so I have this. All right, so here I'm going to have my voltmeter because it has to be in what? In parallel. Then this is unknown resistance, or you call it resistance box, and this is what? Rheostat. Now watch, this one is no longer here. Now, what are the things you need to understand in this diagram? You know, this is how the diagram is going to be given. But you see where the problem comes from. You find it difficult to identify which one is positive and which one is negative. That's the number one problem we always have. And once you are unable to identify this, you cannot have a successful connection. So let's see how to identify positive and negative. Note, the following circuit elements, that is the following electrical loads, they don't have positive or negative terminal. Your rheostat does not have negative or positive. Your resistance box does not have negative or positive. Your resistor does not have negative or positive. But how do you determine the negative and positive of all these things I mentioned? Now, this is it here. This is a battery. The battery has a positive and a negative pole. This long pole is positive. This short pole is what? Negative. So if I have a Tiger battery, which is the common cell that we always have, the top of it here is the positive and the base is what? Negative. Note that. So the positive pole of what? Of this Tiger battery is going to be connected to the positive pole of the ammeter. What is the positive pole of the ammeter? This is the positive. This red one is the positive pole of the ammeter. So, sorry, this voltmeter. Yeah. So I have my ammeter here. So the positive pole is this what? This red. Are you getting it now? Now let me explain something to you about this ammeter. This ammeter is capable of reading up to 5 ampere and also 3 ampere. There are some ammeter that they can only read 5 ampere, while some they can only read what? 3 ampere. So if you, like for example now, this particular experiment now, we are going to have a very low current. Why? Because the expected source of EMF, they said it should be what? 2 volts. And even if they don't tell us that it's going to be 2 volts, our battery, that is the Tiger battery, is 1.5 volts. So if you have 2 of it, you have 3 volts. So 3 volts cannot produce what? A current of 5 ampere. Am I making sense now? So it means you need ampere that can read just 3 ampere. You need ammeter that can read 3 ampere. So if you are using this kind of ammeter that can read 3 and can also read what? 5. All you need to do is to connect your positive pole to this first one, mark 3. Am I making sense now? So the reading at the top is for this one. The reading below is for this one. Is that taken now? So you connect the positive pole to this side. So this place is going to be the positive pole of the ammeter. If here is positive pole of the ammeter, here is going to be what? The negative pole. So this negative pole is what I am now going to connect to this resistor. Are you getting it now? So the other end of this resistor is what you are going to connect to one end of the rheostat. Am I making sense now? And the other end of the rheostat is going to be connected to a key. Am I making sense now? So connecting that end to a key, the other end of the key is going to be connected to, what is it called? The negative pole of the battery. Remember, all these key, rheostat, or non-resistor, they have nothing to do with positive or negative. What you need to pay attention to are these ones that have something to do with positive and negative. Make sure that you trace all these lines. All these lines are wire. The positive pole of the battery go to the positive pole of the ammeter. The negative pole of the ammeter come down to the rheostat. And the other end of the rheostat go to the key. The other end of the key, so that for those of us who don't know rheostats, because it's another aspect of questions like sending me picture, asking, oh, what instrument is this? This is rheostat. And you can see these are the 2 terminals. Are you getting this now? So this is where you vary the resistance. Can you see? You move this to vary it. Am I making sense now? Alright? So one end, that is this negative pole of the ammeter will come to one of this leg, and then the other leg is going to the key. Here is the key here. Can you see? And the other end of this key is coming to the base of the battery. So what about this? This one is going to be connected in parallel to this resistance here. This resistance here is the resistance box. Am I making sense now? So you have this resistance box. So for that reason, your voltmeter is going to be parallel to this resistance box. So if you have to do that, all you need to do is that this place is going to be the positive pole of the voltmeter, and here is going to be what? Negative pole. Am I making sense? And I hope you are getting this. So if you are able to do what? Do your connection like that, you are going to have a nice reading accurately. But there is possibility that you connect swiftly like that, and yet your reading is not reading. That is, all your ammeter voltmeters are not reading. This is what you do first before you connect. Test all this ammeter. Get a connecting wire. Start from the connecting wire. Don't get a connecting wire with high resistance. Get a connecting wire with low resistance. This black and red. It's cool. So make sure you clean the terminal of your apparatus. Clean the terminal. When you clean the terminal, what I mean by cleaning the terminal is this pole. Some of them must have rust at times, so they don't have a proper a proper connection. So clean it up, test it. Connect wire to it directly, put it on the battery, make sure it deflects. If it does, check this also, make sure it deflects. If it does, then you are sure that they are working. Am I making sense now? So the next thing is clean the terminal of this also. Make sure that all the apparatus you want to use, every of their terminal is well polished. So once you are able to do that and you make your connection, you are going to have a successful reading. But if you don't do that, there may be problem. It is probability. You might have result, the result might not be accurate. You might not have result at all. Am I making sense now? And I hope you get me clear. Alright? So if that should be the case, this diagram that you are seeing, examiner can change this diagram in another form, and it will still be the same thing. Are you getting where I'm coming from now? Because you as a student now, your teacher already carried out some experiments with you for pre-practical so that you know what you are preparing for. Then getting to exam up, you see them changing the diagram. Then you think you have not been taught. You have been taught. For example, look at this diagram here. Look at this other circle diagram. Okay, so let me clean this up. Can you see this now? Let me clean this up. We really do not need this anymore. Look at this circle diagram here. If I have this, okay, this comes down like this, and this is what I have here. So, okay, and here is my key, and I have my cell here, and then at this point I have my ammeter connected to this place. Then I have my voltmeter connected like this. So this positive, negative, negative, positive, then positive, negative. If I have this, remember, this is your rheostat, and this is your resistance box. So if you look at this diagram right now, they are not the same, right? But it is still the same thing. A bent wire is also what? A straight wire. This wire you are seeing here is still in series with this battery, just like this one is in series, and this one is parallel because this wire is connecting to this wire here. This is a node. This is also what? A node. There will be split of current here. Because there is a split of current, the current that will enter into this node is going to split into two. It's going to split into this direction, another one will enter into this place. That's why you know that this one is in parallel. But if you look at this one now, the current that is flowing like this is just flowing directly. That's how you get to know that this is what? This one is in series. So, and if you look at this and this one, it's still the same thing. So, changing diagram should not let you confuse as a student. That's why you need to understand when they are in series and when they are in parallel. I hope I'm clear now. So those are the things that brings about problem. Once you miss the terminals, there will be problem. There are times when you want to pick your reading, you get to see that it deflects towards the negative what? Negative sides, which is not supposed to be. So if that happens, know that there's a mix-up in your terminal somewhere, and you need to fix it. I hope that is clear. So if that is clear, another thing you need to do is that each of your wire, don't manage wire. Make sure it is as long as at least 50 centimeter, if not 100 centimeter. These are things you need to get aware of before you start this practical. Now, for the last thing I'm going to talk about is the meter bridge. Now, if you look at the circuit diagram I use as an example for you, there is no meter bridge there, and there is no what? Jockey. Now, examiner now bring in meter bridge because they don't want you to know directly that it is Ohm's law that they want you to prove. So they now want to bring in another factors that you need to consider. Why are they bringing in another factor, which is meter bridge? You need to understand that anything that affects resistance is going to affect Ohm's law. So what are the factors affecting resistance? One of it is the length of the conductor. So trying to test the length of the conductor, that is where the meter bridge comes in. Are you getting this experiment right now? So you are still in the realm of verifying what? Ohm's law. So you can predict and tell if your reading is correct or wrong, because you already know that Ohm's law is V equal what? RI. Am I making sense now? So as resistance is increasing, what will be happening to current? Current is going to be decreasing. Are you getting it now? And when you look at it, R is proportional to what? Length. The longer the length of your conductor, the higher the resistance. That means as you are changing the value on the meter bridge, okay, what will be the resistance, or what will be the current, or what will be the voltage when the length is 70? What will be that when it is 75? What will be that when it is 80? As you are increasing the length, what is happening? Current will be reducing. So understanding all of this theory is what lets you know if what you are doing is correct or wrong. Because that's a case, before we even finish, we start doubting our results. Am I correct? Leave that doubting. Understand the theory that binds the experiment you are doing. Once that theory, you understand it very well, you can use that theory to know if your answer is correct or wrong. And that is one that I just explained to you now. Am I making sense right now? So, some teachers or students or people selling apparatus, some of us or some of them find it difficult to differentiate between meter bridge and potentiometer. Now, I want you to understand that when it comes to meter bridge, we have two types of meter bridge. We have Wheatstone meter bridge, and we have meter bridge itself. Am I making sense now? So we are here to order for the meter bridge, and that is why I'm going to need your support. I've always been asking for that, so that we can have a full lab setup, because very soon I might not be chanced or be opportune to have schools that I'm going to be using for this kind of experiment. So I'm waiting for the schools to get their apparatus. If they does, you gotta see me there. So this is an example of what a Wheatstone bridge meter, rule. That is Wheatstone meter bridge. An example of Wheatstone meter bridge is what I have here. Can you use it? Yes, you can use it. And I can tell you categorically, it's the most common meter bridge that you can find around now. So how are you going to use it? I'll be explaining that on Wednesday when I'm doing the practical. So don't confuse this with this. This one is called potentiometer. So when you look at it, it has just two terminals. You can look at, just make sure you see the difference. For this one now, that is the Wheatstone meter bridge, is having up to 9 terminals. Is that okay now? So these are things that you need to get cleared of before the main practical. So by God's grace, God willing, Wednesday I'll start dropping the main practicals. So tomorrow by His grace, I will also talk about the necklace. I'll give you what you should be expecting. Then next week we'll start by doing the appropriate practical together. But I want you to watch and share this video so that you know what to avoid, what to do before you even start the experiment itself. It's very important we get to know all of these things. And by His grace, a prayer time permit me, I'm going to be drawing I'm going to take you through how to draw some difficult graphs under electricity. Okay, so thank you so much for spending time with me, watching this video to this point, and I believe you are already sharing the video with your friend. Share it on Facebook, share it on WhatsApp group. It's going to help somebody, and I believe it has helped you also. Please help others. Let me know what you learned. Let me know if this video is helpful to you in the comment section. It's very important for me to know. Your comment is what determines the kind of content I'll be creating for you. And if you'd like to support the cause of this channel, of course, the money is not really there. We are just trying. Are you getting this now? So don't make us a beggar. If that should be the case, you can also assist the cost of the channel. 1,000, 2,000, 500, nothing is small. Check the description box. You're going to find the account details there. Anything you put there, God is going to bless it for you. And then, till then, see you guys on Wednesday.